was so into the groove, I started solving it without recording it. Okay, so here's problem 2 with homework 14. We have a shaft with pulleys as part of the machine, the U-Hart HVAC system. It's operated at constant speed on frictionless bearings at O and C. And the tensions are 25 newtons, 15 newtons, and we got 32 here. We don't know FB2. Oh no, we don't know FB1, but we can find it. The dimensions are 250 millimeters, 200 and 150. This is 125 radius. This is 75 radius. And we need to make sure we do FBDs. So I already wrote out the problem ahead of time and kind of got a little ahead of myself and started actually writing the FBD. So the first FBD I want to do is down the x-axis, looking down the x-axis. I'm doing that so that I could find that unknown here, because we're going to balance the moments about the x-axis right here. So I'll take the moment about the x-axis. I didn't write out onto here. It's kind of hard to squeeze everything in. Didn't write out what the radii were. This is 75 millimeters. And this is 125 millimeters. Right in there. I squeezed them in. And so let's see. I'll start it with the 25 because he's counterclockwise. 25, and we're going to use the 125 with that, whereas his buddy right here, he's 15, and he's also times 125. And we could have taken a shortcut by, I said 25 minus 15 times 125. Totally could have done that. We're going to say a minus 32 times 75, and then we're going to have a plus FB1 times our 75 equal to 0. And we'll solve for our FB1, and we'll be excited to find out what we get. It'll be Thrillsville. You're so excited. I know. You can hardly stand yourself. Great. So it's 25 times 125, and I could have done the thing I said I was just going to do, but I didn't do it. Subtract that out. And then we have 32 times 75, and that's going to be times, but we're going to subtract that out. We get a negative number, which we expect right there because it's going to go on the other side of the equal sign right there. But we divide by 75, and we find that it's 15.33 newtons. Right, so just double checking here. This is the large side. It wants to make it go counterclockwise. This is the larger. It tries to make it go counterclockwise. So it makes sense. You just want to double check. And now, excuse me, I make the FBD, the side view. I'll do the XY first. And this is the bigger one. It's nice to make them kind of give some sense of scale. It doesn't have to be to scale, but it doesn't hurt. So in this view, looking from the side, you don't see anything on this right there, right? So because these are coming at your face. But this one you're going to see upwards, and they're going to combine together. Right, so it's going to be our, which one? 32 plus 15.33. So is that 47.33? Right in there. And so reactions are going to be downwards for both of these. So this is going to be ROY, and this will be RCY. And the dimensions, let's write them on here, is 250 millimeters, 200 millimeters, and 150 50. So we take the summation of moments about the O and we're going to have clockwise, counterclockwise, 47.33 is counterclockwise. And that's going to be 200 and 250, so 450. And now this one's clockwise, so RCY. And so we're going to add 150 to that. Does that make 600? I believe it does. Yeah, because that would be 550 and then 50. Yep, okay. So we get RCY of our 47.33. 450 times it and 600 divided, and we get 35.50 newtons. Move my keyboard out of the way. Okay. And then we do the sum of the forces in the y direction. And so we're going to have a negative ROY. We're going to have a positive 47.33. And then we're going to have a negative 35.50 equal to 0. So we get ROY equal to 47.33. We get 11.83 newtons. We're going to make it onto one page. I don't know. We might make it. We'll do the XZ axis here. So let's draw this guy out again. Call it an FBD. We'll call it a comeback. Crowd's never gone. Okay, so when we're looking down at this thing, all right, so I guess I'm going to put this X there and the Z that direction. We're looking down onto this. We're going to see these things going in the positive Z direction, right? So let's draw them right here in the positive Z direction, and they're going to add together, and it's 25 and 15. That makes 40 newtons. And so the reactions will be in this direction for both of them. So that's going to be ROZ, ROZ, and this is RCZ, RESI. And we still have the 250, 200, and 150 right there. And we will have the sum of the moments, taking it about O, right? And it's actually OY if you want it to be true, and this one right here would be OZ if you wanted to fix that up there. I went ahead and put it in there. It's equal to 0. Counterclockwise is positive. So we take negative 40 times 250, and we add our RCZ times our 600. We get RCZ equal to 40 times 250, boom, 600 divided 16.67 newtons. Then we take the sum of the forces in the Z direction. Downwards is positive in this case. So we have a negative ROZ and a positive 40 and a negative 16.67. So we're going to have an ROZ equal to 23.3133 newtons. And so now we want to get the magnitudes of these. So I'm going to say that RO is the square root of 11.83 squared. That's supposed to be a squared. And then 23.33 squared. I use really big lead as the 0.9s, and I wanted to buy a bunch more of these pens, so I bought like 10 of them, but they sent me the wrong one. I have like 0.5s at home, and now I don't know. I'm starting to think it's like too fat. I might try those 0.5s out again. Maybe I'll get some good leads or something. Get the lead out. Let's see. I'll flop those around and square them and add them and square root them, and I get 26.16 newtons. And here's my RC, square root of 9/11 at night, 35.50 squared, and 16.67 squared. So he's going to be the big winner chicken dinner of 35.5 squared and 16.67 squared, atom square root, and we get 39.22 newtons. So the answers on one page. Why? Because I can. Answers RO is 26.16 newtons, and RC 39.22 newtons. And box your answer, please. Ta-da! I do believe that's what was asked, and I do believe I might be going home. Good night.